Lesson 1.2. This video is a continuation of Fundamentals. 1.2 provides a review of pressure. Pressures of liquids and gases are of significant importance in HVAC applications. Understanding pressure is fundamental to the study of psychrometrics because pressure has a direct effect on the properties of moist air. In order to understand pressure, it is necessary to understand the concept of force. This is because pressure, by definition, is force per unit of area. And written as an equation, pressure is equal to force divided by area. Sounds simple, right? Well, actually it is simple. Pressure is a very simple concept. If the force is measured in units of pounds and the area is measured in units of feet, then the units for pressure would be pounds per square foot. And we often see this written as PSF. An example in calculating pressure is shown here in example 1.2.1. Assume that we have an open tank and this tank is filled with 3,000 pounds of water. The dimensions on the tank are 2 feet by 3 feet. The question is, what is the pressure exerted on the bottom of the tank? So the solution here is to use the equation for pressure as pressure is equal to the force divided by area. In this example, the force is the weight of the water, which is 3,000 pounds. The area is the area on the bottom of the tank, which is 2 feet by 3 feet, which equals 6 square feet. Therefore, the pressure is 3,000 pounds per 6 square feet, which is the same as 500 pounds per square foot, written also as 500 PSF. Or put another way, the water in the tank exerts 500 pounds for every square foot on the bottom of the tank due to the weight of the water. Pressure is a very simple concept, but it tends to get confusing due to the variety of applications and units that are used to measure pressure. As in this example, pressure is measured in pounds per square foot. It can also be measured in pounds per square inch, and often we talk about barometric pressure, typically given in something called inches of mercury. HVAC systems very often measure pressure in inches of water column, and plumbers like to use a measurement of pressure in feet or feet of head pressure. Understanding pressure is of great importance in HVAC applications, and different applications measure pressure in different ways and in different units. This slide is to help understand the relationship of measuring pressure. The atmosphere exerts pressure on the Earth due to its weight. At sea level, the height of the atmosphere is greater than at higher elevations, for example, say Denver. So the atmospheric pressure is going to be greater in San Francisco than it is in Denver. Pressure gauges often measure the difference between the fluid pressure and the atmospheric pressure. So there is going to be a relationship between the pressure measured by the gauge and the atmosphere. To understand this relationship, let's first start with something called zero pressure. The pressure due to the weight of the atmosphere is called the atmospheric pressure, which of course is going to be some value above zero pressure, shown as the blue line here in this slide. Pressure measuring devices typically measure the difference between the pressure of the fluid and the atmospheric pressure, shown on this slide as the red line. We'll call that gauge pressure. Typically, gauges are calibrated to read 0 at atmospheric pressure so that the reading you get, the gauge pressure, is going to be the difference between the measured pressure and atmospheric pressure. Absolute pressure, gauge pressure, and atmospheric pressure are related by the equation P absolute is equal to atmospheric pressure plus gauge pressure. As noted earlier, the pressure exerted by a fluid will depend on the weight of the liquid or the gas. The weight, which is the force exerted, depends on the height of that liquid and the density of the liquid or gas. This makes sense because if you think about it, a liquid that is more dense will exert a greater force than a less dense fluid for the same height of column of fluid. This relationship is written as an equation, P equals density times height. So if there are two columns of liquid of equal height, if they have different densities, they will exert different pressures. If the density is in units of pounds per cubic foot and the height is measured in feet, then the units for pressure are shown in the equation pounds per cubic foot times feet equals pounds per square foot, and that's PSF. Let's consider another example, example 1.2.2. In this example, a 50-foot high open pipe is filled with water and extends from a condenser on the top floor of a building to a cooling tower on the roof. The question is, what is the pressure that is exerted on the condenser due to the water in the pipe? And give the answer in units of pounds per square inch, PSI. To solve this, we use the equation for pressure where pressure is equal to the density of the fluid times the height of the fluid. In this case, the density as the density of water is assumed to be 62.4 pounds per cubic foot, and the height is the height given in the example as 50 feet. The pressure then is 62.4 pounds per square foot times 50 feet, which equals 3,120 pounds per square foot. But the question was not in PSF, but in PSI, pounds per square inch. To do so, we simply apply unit analysis to convert square feet to square inches using the factor 1 square foot is equal to 144 inches squared. Doing the math, we see that the answer comes out to 21.7 pounds per square inch. Please note, this is gauge pressure. Why? Because if we put a gauge at the bottom of the column, the pressure would read 21.7 psi. If we were to move that same gauge up to the top, we would notice that the reading would go down until at the very top it would read 0. This is because the gauge is calibrated to read 0 at atmospheric pressure. So the gauge is reading the results of the pressure due to the water only. Let's look at one more example, example 1.2.3. In plumbing applications, the term head pressure or feet of head is often used as a metric to measure pressure. And we often see a conversion factor that plumbers have to use where 2.31 feet of head is equal to 1 psi. The question here is, derive this conversion factor. To solve this, we'll use the equation pressure is equal to density times height of the column of fluid, where P, pressure, is going to be set equal to 1 psi and D will be the density of water. First, we need to convert 1 pounds per square inch to pounds per square foot. Also, we'll rewrite the equation P equals density times height as P divided by density to equal height. Now substitute 144 pounds per square foot, which is the same as 1 psi, and insert 62.4 pounds per cubic foot for density. And we get the following: 144 pounds per square foot divided by 62.4 pounds per cubic foot. Using math and a careful check of the units, we see that this equals 2.31 feet. This concludes a basic review of pressure. The next tutorial provides a review of enthalpy and sensible and latent heat.